Hello everyone, this is Andrea Clayton. I'm presenting my Teach 1 for HAP823 Comparative Effectiveness, term of spring 2020, taught by Ronald Woodaman, PhD. The topic is logistic regression, which is the week 2 question 3. Just a quick review of logistic regression is that it is a method of predictive analysis used when the dependent variable is binary. It explains the relationship between one binary dependent variable and one or more independent variables. The independent variables can be either nominal, ordinal, ratio level, or interval. The assumptions of logistic regression include the dependent variable should be dichotomous, meaning either it's present or absent. Observations are independent. There's little to no multi-collinearity among the independent variables, linearity of independent variables and log odds, and large sample size. So the week 2 question 3 reads as, the following data provide the length of stay of patients seen by Dr. Smith and his peer group. Does Dr. Smith see a different set of patients than his peer group? In particular, what is the probability of patients seen by Dr. Smith? And regress the choice of provider on the 9 diagnoses provided. So here's the data that we're given in Excel format. You can see the headers at the top with the 9 diagnoses. It's all binary. 1 is the presence of the diagnosis and 0 is the absence of diagnosis. For the column which is highlighted in green, the cared for by Dr. Smith, 1 is the patient was cared for by Dr. Smith, and 0 would mean that the patient was cared for by the peer group. And then the length of stay, which is in column K, is not used in this assignment. So cared for by Dr. Smith is going to be the dependent variable. So we'll need to import this data into R. I personally am using RStudio. It's just easier to look at and see your work and your formulas at the same time. So you're going to convert your Excel spreadsheet into a CSV file for import into R, and then import the CSV file into R, which I'm sure you all know how to do now. So I just included the read command for R. It's read.csv, and the file will be your file path and file name, and header equals true. And where you see the red arrow, this is mine importing into R. So the path, the file path and file name may be unique to you and whatever you wanted to use the name to be. And then you can see that it's listed the the column headers, which are the diagnoses there, and the binary values. We're going to create a data frame with the imported data. So we're going to use, I called mine Dr. Smith. Here you'll use Dr. Smith and read.csv, your file equals, and that'll be your file name, header equals true. To check the class to make sure that you did make a data frame, you can check class and in parentheses Dr. Smith, and that will return what kind of file you just made. And in here it says data frame. We use the str parentheses command, which is for structure, to inquire about the structure of the data. It's on the right-hand part of the slide. And this will show us how many observations, how many variables, what kind of variables they are. They're all integers, and that they have binary values denoted by the 0, 1s. So to get a summary of your data, you're going to use summary parentheses, and inside the parentheses you're going to put your data frame's name. So again, mine's Dr. Smith. And this will come up with your header or variable names and columns. It contains the minimum, the maximum, the median and mean, and the first and third quartile values. So you can see we have 9 binary diagnoses, which are independent variables. Our one dependent variable, which is binary, which is cared for by Dr. Smith, and one continuous independent variable for length of stay, which is not used in this question. And we're going to model the data for regression. So I'm going to name mine Model Smith. The formula will be equal GLM, that's the command for the generalized linear model. The dependent variable is cared.for.by.dr.smith. Make sure that you have it exactly how it's denoted in the structure or it will not read. Then we're going to use the tilde. This is used to separate the sides of the regression formula. So on the left side of the tilde will be your dependent variable, and on the right side will be your independent variable or variables. Here we're going to use all of the independent variables in the formula. So we're going to use the period, which signifies everything. And then comma, data, we're going to name the data frame, which again is Dr. Smith. We're going to ask it to use all of the rows. So in the brackets, so it'll be a comma for all the rows and the variables 1 through 9 out of this data set. And then comma, family equals binomial. Now this is a link to the linear model to do the logit, which comes in later. So in your summary of the model, so we're going to do summary parentheses Model Smith. Remember, that's what I called mine. You'll see the call, and then there's your original formula. And then it gives us deviance, residuals, and coefficients, etc. So using the alpha of less than 0.05, the summary will show variables significant to the dependent variable, which is which is cared for by Dr. Smith. And the significant diagnoses are denoted by the 3 asterisks. So that is heart failure and metastatic cancer. So what we're trying to find here is the first part of the question on what kind of patients are seen by Dr. Smith. Does he see a different set of patients than his peer group? So this significance means that patients with heart failure and metastatic cancer are 0.52 times less likely to be seen by Dr. Smith. You see the negative 0.52 under the coefficients, and then they have the 3 asterisks at the end. So now we need to calculate the probability. I'm not going to take credit for this formula. This formula I found, or this code was found on a previous Teach One by Sneha Kavalu. If you have a chance to watch her Teach One, I included the link there. So the name of the model, I'm naming it logit prob Smith, and then we're going to call up the function logit to calculate the odds using the exponent of logit, and then you use the odds divided by the 1 plus odds to calculate the probability, and then you return the probability to get a list. So to print out or view the logit prob Smith data frame, you call that up with the coefficients, and this will give you the diagnoses and the coefficients. Now this shows us the probability that the patients will be seen by Dr. Smith. And that's it. So we've answered the question. Does Dr. Smith see a different set of patients than his peer group? And in particular, what is the probability of patients being seen by Dr. Smith? And we have regressed the choice of provider on the 9 diagnoses provided. So Dr. Smith does see a different set of patients compared to his peer group. He sees less patients with heart failure and metastatic cancer. There's a 37% probability that these patients see Dr. Smith versus 63% they will see the peer group. the probability of patients seeing Dr. Smith giving these diagnoses. So for hypertension, HIV, and stomach cancer, there's a 50-50 chance that you'll get Dr. Smith or his peer group. For diabetes, lung cancer, and anemia, there's a 49% that the patient will be cared for by Dr. Smith, 51% probability of his peer group being seeing these patients. 47% probability for myocardial infarction, while there's 53% probability of his peer group seeing the myocardial infarction patients. Thank you for listening and watching. Special thank you to Sneha Kavalu for her excellent Teach 1, an important piece of the code that I was not able to find elsewhere. And I thought I'd pass that along to you guys. So take care, and there's my email if you have any questions. Good luck.